Hi guys, this is Mrs. Gastler, and in this video we're going to talk about position versus time graphs. And I've got one right here that we're going to use to look at. And the first thing we're going to talk about, I'm going to make a note here, my pen's not clicked, is that you should listen to this video. If you are currently just watching this video and writing stuff down, you are going to miss stuff. Because I'm going to say stuff that I'm going to not write down, okay? And so, because I just don't want to write it all down, okay? So here's the deal, and sorry about the wiggly camera. I'm at home, and this table is wobbly. Okay, so position versus time graph. So we're going to have position on the y-axis, and this is where it gets a little confusing because a lot of times we use x for position, and it's confusing to have x on the y-axis. I know that's confusing. You'll get over it eventually, but this is t on the x-axis, and so this becomes an x versus t graph, and that is the shortest way that you could possibly write the title for this graph if you have to write this title. For this graph, x versus t, and this is kind of a busy graph going on here, and what this thing tells us is that the position over time, and so we can follow our car. It is clearly moving away from zero as time goes by. This is a nice straight line. It's not changing as we go. It's a nice straight line. It's not flat. Some people like to call this a flat line, but it's not flat because it's going up at with a slope. Okay. And then it reaches this distance, this position of 6 meters at 2 seconds, and then it goes back down. Here it's straight, and then here it's not straight. Here it's kind of curved, and then it continues back up at a nice straight line there again. So we can see what our object is doing as it goes away. So it goes away, and then it comes back, and then it goes away again. Okay. At some point in time, you may have to describe what an object is doing based on what you see in the graph. So what can we get from the graph? What we can get from a position versus time graph? The main thing that we can get, and there's really only one thing that we can get other than what the object is doing, comes from the slope of a position versus time graph. And what I like to do is I like to think about what a slope is. Well, when you find slope in math class, it works exactly the same here. Slope is change in y over change in x. And again, this is where it gets confusing. So I'm going to write some extra words here. On the y-axis, I have position. So that's change in position over the change in time. Now I wrote position out because it's the x thing there. Right, so change in position over change in time. Hopefully you've already figured out that that is a velocity. So the slope of an x versus t graph is the velocity. Okay. That means that I can tell how fast an object is going by looking at the object. Okay. Now, if the magnitude, right? So if I drop the positive or the negative, if I just look at literally how big the magnitude of the slope is, that's going to tell me the speed. Okay, so if a question is asking you about the speed, then it's literally asking you about how steep it is, and it doesn't matter if it's going up or down. So this right here is not quite as steep as this right here. So it's just a little bit steeper right here than it is right here. So this is actually faster. Okay, so this is a faster speed right here. It's going in the negative direction right here. It's going down. That's going to be a negative slope. This one's going to be a positive slope, negative slope, positive slope, but this one's going faster. Okay, so if you get caught up there, make sure you look at whether or not your question is asking about speed or velocity. Okay, so that might come into play at some point in time. Now, when you are calculating the slope, okay, there's a couple of things that you need to pay attention to on the AP test. Okay, the first thing you need to pay attention to, I guess if all you have is a straight line, then what you need to think about is the only thing that you really need to think about is making sure that you choose good points. Okay. choosing good points is essential, okay? Choosing points that are easy to read make it very good. If I zoom in, can I zoom in? Zoom in, there we go. Now it's kind of grainy, sorry. So this is a good point because I can see it crosses these grid lines. That's 0, 2. La la la, that's a good point. It's halfway between 0 and 1, so that's 0.5. And it's halfway between 2 and 4, so that's no, that's just 3. Okay, there's another one and another one and another one. So where it crosses grid lines make it easy to see. There's another good point. Now this part where it's curved, now that's kind of tricky right there. We'll talk about the curved lines a little bit later. And then over here on this one, there's a good point right there. That might be a little hard to read, but I can always, I can extend my scale. Okay, so here's 5 and 6, so this would be 5.5, and this would be 5.25. So I know that this point right here is 5.25 and 2. That makes it, oops, you can't even see what I'm doing. There we go, 5.25 and 2. That makes that an easy to read point. As long as I'm choosing points that I can easily read, those are good points to use when I'm calculating the slope. That will make my calculations better, and that is going to be great. If your line is not straight, or you are using a best fit line for best fit lines, if you have a best fit line, don't use data. Don't use data points unless they are right smack dab on your line, okay? Using data points is a bad idea. If they're on your line, that's okay, but the AP grader who's grading your test is going to be way more likely to give you points if they're looking at the points on your line, and circle the points that you use. Okay, so we'll practice getting a line here, what do you call it, a slope here in just a second. Okay, write the work that you do. Okay, in AP Physics, you have to show your work. Very, 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 very occasionally will they actually give you points without showing work, and that is almost never. Okay, so always show your work. You are more likely to get points. Write an equation down, put some numbers into it, and then put your answer down, and you are way more likely to get points on the AP test. Okay, so show your work. And make sure you include units on your answer. That's going to help you out too. Okay. I think in all of my grading, leaving a unit off meant I didn't give the point. Okay. So make sure that you don't leave your unit off. Okay. So let's practice that. So we're going to choose some good points. We're going to write the work that we do, and then we're going to do it. So I'm going to fold this up like this. Okay. Hopefully I didn't have my hands over that the whole time and you were able to read that. Okay, so we're going to find the slope. So first let's find the speed. Let's find the average speed. Okay, the average speed between time equals 2 seconds and 4 seconds. So this is a question that you might have to answer. So when it says average speed, that means that I'm really looking at between 2 and 4 seconds, okay? So I'm going to put my points here and my points here. Let's see, do I have something I can use as a ruler nearby? Okay, this is going to be strange. I have this Lego, how to build this manual thing. I'm just going to use that as a ruler because that's what I got, right? Got to use your resources. Okay, so there we go. There's my line. I'm not going to use data points in between there. I'm going to use the endpoints here. So between 2 seconds and 4 seconds. So I'm going to write my points down. Okay. So I've got 2 seconds, and at 2 seconds, it was at 6 meters. That's a 6. And at 4 seconds, it was at 1. So that's in between the 0 and the 2. So 1 meter. Okay. So now I'm going to find the slope because that's my speed. I can even write that, right? Speed equals the slope. Sometimes you have to write this in order to get a point too. So making a note that the speed equals the slope or velocity equals the slope is a valuable thing to do. It's looking for speed, so I don't care if it's positive or negative. I can probably leave the negative on there and it'll be just fine. Okay, so I need to do my change in y over change in x. I could also write the change in position over the change in time, and it would be just fine. Let's see my numbers. Sometimes you can skip steps, and it's okay. I'm just going to go ahead and write those in. Change in y is going to be the 6 minus the 1. Let's see. We'll do the final minus the initial. So 1 minus 6 meters. Leave those in there. And then the 4 minus the 2 seconds. Okay, 1 minus 6 is -5. 4 minus 2 is 2 meters in seconds. So let's see, that's going to be 5 divided by 2.5 meters per second. And I dropped the negative, but that's okay. Okay, so there we go. So that's the average speed. Okay. Now, sometimes it's going to say what's the instantaneous speed. And the instantaneous speed is the speed right at a particular time. Instantaneous speed or velocity. And so it's going to say a particular time. And let's go with at 3.5 seconds. And there's a reason I picked 3.5 seconds. And so this is an interesting one. I'm going to bring another graph over here so I can show you this too. Okay. So I've got this other graph here that does this other thing. And you may have seen this one because we looked at this in a lab where we saw an object accelerating, right? Gosh darn it, this thing is wiggling all over the place. I'm so sorry. It's like we're in a live action movie, right? So if you took physics first, you may have used or heard of at some point in time something called a slopometer, which is just a writing utensil. And you may have used it to figure out what is happening to the speed, because the speed on a position versus time graph is the velocity. And so when the slope is changing, you can use your slopometer to think about how that is changing. And so what you do is you just make it parallel at a particular point, and then as the slope changes, you just turn your pencil to follow that slope. See what I'm doing there? Okay, so it's definitely slower here, and it's getting faster and faster and faster. Okay, and so this is your handy slopometer, and you can use that to think about what's happening to the speed if you need to. Or you can just use your eyeballs. Okay, you can probably see what's happening to the slope without using your pencil. And so what I'm going to do at 3.5 seconds, there's 3.5 seconds. This is what I need right here. Now that part of the graph is in the middle of a curve. So what I'm going to do is I'm going to take my handy ruler, also known as a Lego direction manual, and I'm going to draw a nice long line right there because I'm going to need to find points. So I need to find points where it crosses the grid. Ooh, there's one. And I'm going to circle it because that will help the AP grader figure out what in the world I did. Ooh, and there's one right there. There's 2. Okay. So I found 2 points that touch my line right here. That one doesn't cross the grid, but that's the point that I'm looking for. And these 2 points I'm going to use to find my slope. Okay. So then I'm going to do it the same way I did here. So my points, which I don't have to label as points. I mean, you can just write that down, right? So I've got 0.5 seconds and 4 meters. And what is that? 4.75. Gosh, I'm going to need a calculator. I don't have a calculator. I have to do this math in my head. Or you're going to do it later. And then you're going to tell me what the answer is. And 0 meters. Okay. Well, I can totally do that math. Okay. So my instantaneous speed is still the slope. And so I'm going to do the change in position over the change in time. See, I wrote it differently than I did here, and that's totally okay, right? So let's see, I went from, 0 minus 4 and 4.75 minus 0.5. Okay, well, I can do some of this math. So let's see, that's minus 4 meters on top and minus 4.25 seconds on the bottom. That's like point something. It's definitely point something. You're going to do that math and you're going to fill that in, and then it's going to be meters per second. Okay? And so that's what we're doing to find the slope on an x versus t graph. If you can easily identify what's happening here, and you can make these calculations when you're looking at the graphs, these are things that you're probably going to have to do at some point in time. on the AP test. Okay. If you have questions, ask. And that's all I got. Thanks for watching.